Good morning, Tara. Good Friday morning to you. Tara, I have a stopwatch here beside my computer I'm going to use. You might hear a beeping sound. What I'm going to do is I noticed yesterday's video was 31 minutes. Again, if Mr. Harmon's in the room, I would like to defend myself. It's very difficult to know how long to run a video. Usually I can compensate for longness or shortness of a video by giving homework or stuff like that. But usually when I review again, Tara, and right now as I'm talking, the stopwatch is running. But usually when I review, I just use the whole hour and then maybe give the students a little 5 to 7 minute break at the end because I've lectured the whole time. What I'm going to do from here on out is I'm going to time the videos for 35 minutes. Now that gives 15-minute cushion. In case a couple times, I know what it's like. Mr. Harmon's busy. He might get there 1 or 2 minutes late and start the video late. You might be late, Tara. There could be some hang-ups. It might not start right away, whatever. And plus that gives some extra time also to pause the video, because I'm no longer going to say to you, okay, I'm going to wait a minute while you write this down. I'm just going to go straight through for 35 minutes, and you'll need to pause the video occasionally. So what I'm going to do is every time that I have to take a break or walk away from the computer, I'll stop my stopwatch and I'll restart it, and I'll make sure the video is just about right at 35 minutes. And hopefully by the time you add in all of the unforeseen problems, that should end up being just about a full class period. You might end up, Tara, with about 5 to 6 minutes of free time at the end, but that's pretty good. So, all right. Well, let's very quickly remember we talked yesterday about, and you don't need to take any notes right now. We talked about, and I do know what I'm doing. I'm on the wrong page of my notes, so give me a second, please. Okay, here we go. We talked about side, 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 angle, side, angle, side, angle, 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 side as ways to prove triangles congruent. We talked about 5 characteristics of parallelograms. We talked about 5 ways to prove that you have a parallelogram. Then we talked about some things about a rectangle you need to know. The diagonals are congruent and they bisect each other. And we talked about a rhombus. All 4 sides are congruent and the diagonals are perpendicular. So just a quick, literally 30-second review of what we talked about yesterday. And now let's go ahead and get into some more stuff today that will be on your exam. Okay, so here we go, please. Once you write this down in your notes, we're going to talk for a second about trapezoids. This is what it looks like, trapezoids, okay? So we're going to take a look at trapezoids, if you'd write that down, please. And let's go ahead and get a picture of what a trapezoid is. Let's just review again. If I go too fast, you just pause the video. A trapezoid could look, I'm going to go ahead and go like that real quick, Tara, and then go shape recognition. There we go. Okay, that would be a trapezoid. And here's why, Tara, please watch. Notice this side here is parallel to this side here. Notice that this side here is not parallel to this side here. That's it. That's a trapezoid. A trapezoid is a 4-sided figure. I will not ask you to define this on the test, but a trapezoid is a 4-sided figure in which you have exactly one set of parallel sides. So with that in mind, a parallelogram is not a trapezoid. No way, because this side is parallel to this side and this side is parallel to this side. And a trapezoid has only one set of parallel sides, okay? And so this is a trapezoid. And there's all kinds of different shapes a trapezoid could look like. It could look like that. You know, it could look like this, and then over, then out. As long as you have, it could be like this. It could be written that direction. And of course here the parallel side would be there and there. Kinda, not really, not a very good drawing, but you get the idea. So that's what a trapezoid is, and that's what we're going to be looking at today. Now, let me very quickly go back a page and do this and this. And it's not working. Okay. All right. Now, you really need to write some stuff down here, Tara, so please take some really good notes. You need to know this. Okay. This is the parallel side. This is the parallel side. Do you see that? They are called the bases. Okay, draw arrows, whatever you want to do, those are called the bases. Now it's important you know this because later on we're going to talk about finding the area of a trapezoid, and you have to know what the bases are. We're also going to solve for angles in a trapezoid, and you have to know what the base angles are, okay? Now look, Tara, I don't care if the trapezoid is flipped this way, like that, okay? Then this is a parallel side and this is a parallel side. Those are your bases. These two sides here are your bases. I know it looks weird, and you're probably thinking usually a base is something in which it's turned like that, okay? But a trapezoid can be be turned any way you want. The parallel sides are always the bases. Okay, do you get that? I hope you do. Now, with that in mind, then that means that the base angles are the angles that rest on, I'll go ahead and put some numbers. Angle 1 and 2, those come in a pair. We call those base angles. They come together. So we would say angles 1 and 2 are base angles. Base angles always come in pairs of 2. And we would say angles 3 and 4 are base angles. They come in sets of 2. You don't say angle 1 is a base angle. No, angles 1 and 2 are base angles. Angles 3 and 4 are base angles, okay? So keep that in mind. You're going to need to know that. We're going to talk about that a little later. Okay, base angles, legs. Now, these other two non-parallel sides, they're called legs, okay? So this side here and this side here are the non-parallel sides, and we call those the legs. Now again, this is 35 minutes of notes. I know it's not super exciting. It's probably pretty boring, but please give me everything you got for 35 minutes. Everything I'm saying is very important for your exam. Okay, now I'm going to show you some more things. I'd like you to turn over to page 333 while I'm talking to you. So please turn over to page 333. Now, I want to show you a special type of trapezoid, okay? So please turn over to page 333 and please watch this. This is a special kind of trapezoid right here, okay? And what it's called is an isosceles trapezoid. Okay, if you want to write that down, an isosceles trapezoid. I'm going to put trap period for abbreviation. An isosceles trapezoid just means this. The two legs. Now remember, Tara, we just talked about this. The legs are the non-parallel sides. So the two non-parallel sides, the two legs, are congruent. And that's not always the case. Let me go back a page real quick. See, look, this side here, there's no way that side there is the same length as this side here. So they're not congruent, okay? So this here would not be an isosceles trapezoid. It would be a trapezoid, not an isosceles. This is an isosceles trapezoid here, and so if I tell you this is an isosceles trapezoid, and I told you the length of this leg was 8, then you would know right away the length of this leg is also 8. So you see what an isosceles trapezoid is? It's a trapezoid, and of course a trapezoid has your one set of parallel sides, and the non-parallel sides, which are your legs, they're going to be congruent, okay? And that's what an isosceles trapezoid is. Now, there's one more thing I need to show you, then we're going to get into some problems, okay? Now, please watch this carefully. A line, now pretend I cut this leg in half, right there. Pretend that's the midpoint. And then come over here and pretend this is the midpoint. When you connect those two midpoints like this, that line right there is called the mid-segment, if you want to make note of that, okay? Because you do, again, I'm not putting any definitions on the final exam, but you still have to know what certain words mean, or at least be familiar with them, so when I say to you in a problem, find the length of the mid-segment, you know what it is, okay? This line right here is called the mid-segment. Now notice it's a line that connects the two legs. Here's a leg, and here's a leg, okay? It's a segment that connects the two legs at their midpoint, so right in the middle and right in the middle, okay? Now, understand we call that a mid-segment. We're going to deal with that in just a second, okay? All right, let's go ahead and let's try to solve some problems here. I would like you to take all the knowledge you know about trapezoids, and I've already asked you to turn to page 333, so in your notes you might want to make note of where we're at. Sorry about that, my computer froze up. Page 333. Look at the top at number 1. look at the top at number 1. I'm not going to try to be really fancy. I'm just going to scribble it here real quick, okay? There's the trapezoid they give you, and notice they do call it an isosceles trapezoid. It's in the directions. And they want you to find the missing angles, okay? There, 100 degrees. Now, in an isosceles trapezoid, we haven't talked about that yet in the review. We did talk about it during the class, during the year. But base angles are this. They're congruent when you have an isosceles trapezoid. Now notice I didn't say a trapezoid. It has to be an isosceles trapezoid. And when you have an isosceles trapezoid, the base angles are congruent. So remember how base angles come in sets of 2? Here's one of your bases, parallel side. Here's your other base, parallel side. This angle and this angle are base angles. They come in pairs. Got it? So if this is 100 degrees, then what can we call this over here? Yep, you got it, 100 degrees. Now, these angles here are base angles. Because we have an isosceles trapezoid, these two angles will be what? That's right, they'll be congruent. Now, we've talked about this in the past, how a quadrilateral, remember how a triangle, the sum of the interior angles of a triangle always add up to 180? Okay? Well, remember, when we add up the sum of, hold on just 1 second, please. Remember, when we add up the sum of all the angles of a quadrilateral, they're going to equal 360 degrees. Please don't forget that. And we have a quadrilateral, okay? So, think about it. When you add up the 4 angles inside of a trapezoid, they're going to equal 360. We know these two angles are congruent. Now, come on now, Tara, think. That's 100. That's 100. I need to get up to 360. That's 100. That's 100. So that's 200. I'm only left with 160. And if these two angles are congruent, divide 160 in half. That's got to be 80 and 80. Well, let's see if I'm right. Take 100 with your calculator. Take 100 plus 100 plus 80 plus 80. And guess what you'll get? That's right, 360. Okay, so you need to know for your final exam that when you're dealing with not a trapezoid but an isosceles trapezoid, the base angles are congruent. These two angles will be congruent, and these two angles will be congruent. In any four-sided figure, any four-sided convex figure, the 4 angles on the inside added up will equal 360. That's in any four-sided figure. Okay, so when you add up all 4 angles, it's going to equal 360. All right, let's try another one here. Why don't you try this one quickly on your own? We'll go on to another type of problem here. Look at number 2 at the top of the page there. Number 2 kind of looks like something like that, relatively close. And they've written 70 degrees here. Or is that a 79? Nope, 70 degrees. So I want you to go ahead and find these other angles on your own. I am going to start doing it right away. I told you that I've got to really keep track of the video. I've got to time the video for 35 and hope that I'm not being too annoying to you or Mr. Harmon by having you pause it when you need to, okay? And so hopefully you're in charge of the pausing there. But I'm going to go ahead and get right into this so you can watch me or pause it and do it on your own and see if you got it right. That's totally up to you, okay? Okay, in the directions it tells you we have an isosceles trapezoid, and so we know right away that the base angles are congruent. The bases are not necessarily the top and the bottom sides. Please keep in mind, real quick here, Tara, let me do that, and that. To keep in mind that if it was turned like that, the bases are still this side and that side. The parallel sides are your bases, okay? All right, there we go. So this is my base and this is my base because they're the parallel sides. So this angle here, 70, goes with this angle here. They're base angles. And in isosceles trapezoid, the base angles are congruent, so this has to be 70 degrees. Now, all 4 angles together have to add up to 360. So far, we have 70 plus 70, that's 140. I'm going to subtract out 140, and that leaves me with 220. Now, remember, these base angles are also congruent because we have an isosceles trapezoid. So, I know I need these 2 angles to add up to 220. I'm going to cut that in half. I'm going to put 110, and 110. Now, if you take your calculator and add up all these angles, 70, 70, 110, 110, you will get 360. Okay? And so there we go. All right, now, let's go ahead and try something else. I would like you to look down, please, at the bottom of page 333. So in your notes or however you want to do this, remember, the more organized you are, the easier it will be to study later, okay? So page 333, number 4 at the bottom of the page. You do not, I want to say this again, we're going to deal now with finding the mid-segment of a trapezoid. I want to say this very carefully to you. Tara, please listen to me. What I'm about ready to teach you right now does not just apply to isosceles trapezoids. What I'm going to show you right now applies to any trapezoid. Isosceles or not, it doesn't matter, okay? So, here's my trapezoid. I'm going to tell you now, this segment's congruent to this segment, and of course that means that that's the midpoint, which is good. And this segment here is congruent to this segment here, and that's good. That means this is the midpoint like it's supposed to be, okay? So, if you'll look at number 4, notice they tell you one base is 8 and the other base is 14. Now, what I want to show you is simply this. The mid-segment is always half the sum. Half the sum of the bases. Now all that means, Tara, is you add your two bases together. You should remember this, hopefully. 8 plus 14 is 22, divided by 2 is 11. There we go. So the length of that mid-segment is 11. It's that easy. So on the exam, I'm going to have you find some mid-segments of trapezoids. You simply add their bases together and divide by 2. It's really, really that simple. Now, if you'll look at number, they don't give you one like the one I wanted to show you. Let me see if I can find one real quick so you can reference it in your book. Yes, here it is. Okay. Would you please, I'm going to use the same diagram here. I would like you now to turn in your book to page 335. Page 335. And look at number 23, please. Number 23. Now I know, Tara, that my drawing here on the screen is not like the one in the book for number 23, but it's close enough. And we have an X here, and then we have a 9 here, and a 12 here. This is so easy, Tara, so watch this. Look, normally you would take this base and this base, add them together, and divide by 2, and that would give you 9. So when you're going backwards and I give you the mid-segment, just take this mid-segment, and in your head, I want you to double it or multiply it by 2. So in your head, take 9 times, take the mid-segment, which is 9, and double it. You get what? 18. And so 12 plus something right here has to give you this 18. So you know right away x equals 6. You see, listen to me. Whenever you take this mid-segment and you multiply it by 2, and you get a number out here, that's the number the top and the bottom have to add up to. So take notes on that however you want to, but it's really pretty simple. And doesn't it make sense? Pretend I didn't give you that 9 right there. What if I asked you to find that mid-segment? Well, you would take 6 plus 12, and you would get 18, and then you would divide it by 2, and you would get 9, which is what we had right here, 9. So let me very quickly again go over this for you. Please watch carefully. Whenever you're given the mid-segment and you're looking for one of the legs, just simply double the mid-segment in your head, write it off to the side, and then realize these two bases right here have to add up to that number right there that you got when you doubled the mid-segment. So obviously x equals 6 because 6 plus 12 is 18. All right? Okay, Tara, we're going to continue on now, and we're going to look at something, and again, we're just going through the chapters, picking out main important topics that you really need to know, okay? We have talked about triangles being congruent, but we also talked about triangles being similar, and
I like you, Dad.
And I just want to quickly remind you, Tara, what similar polygons are. Specifically in this section, we're talking about triangles, so please watch this. if I have a triangle here that had lengths 3, I don't know, 4 and 5, then I had a bigger triangle over here that had lengths 6, 8, and 10. These two triangles here are what we call similar. I'm going to go ahead and mark this angle congruent to this angle congruent to this angle, and this angle here congruent to this angle. You see, and how much of this you write down is really up to you. I just wanted to very quickly give a little review as to what similarity means before we get into some problems. Okay, Tara? So listen, when I say that we have similar similar triangles, that means this, or similar polygons for that matter. The angles must be this, congruent, and the sides must be this. They must be proportional, and I'll explain that in just a second. In fact, I'm going to explain that right now. This side right here, excuse me, this side here corresponds with this side here. So I'm going to put 3 over 6 equals, this side here corresponds with this side here. So I'm going to put 4 over 8. And this side here corresponds with this side here. So I'm going to write 5 over 10. Now reduce all these fractions and you should get out the same number, the same fraction. 1/2 equals 1/2 equals 1/2. So when we say the sides are proportional, that means when you line up a side with its corresponding side in a triangle, you will get out equal fractions. Now I want to point out to you one more thing, then we're going to move on. It does not matter which way your triangle's turned at all. Even if it was turned like that, you would still know that 3 goes with 6. How would I know that? Well, notice I have one mark here. I'll use a different color. I have one mark here and 2 marks here. So this side right here has 1 mark and 2 marks. Now which side over here has 1 mark and 2 marks? Well, there's 1 mark here and 2 marks here. So this is the side here. So you would still have to match up the correct side. It doesn't matter which way the triangles are turned. You still have to be sure and match up corresponding side with corresponding side. Okay, so that's what triangles, that's what similar triangles are. The angles must be congruent and the sides must be proportional. Okay, so with that in mind, please listen to them. Look at my stopwatch here. We've gone for about 23 minutes, so we've got about 12 more minutes left, at least on this video. Now if you get extra time, more than what I like, then I'm sorry, but again, I'm trying to plan this the best that I can. Now we learned 3 ways to prove, please listen to me, we learned 3 ways to prove that triangles are similar. Okay, and here they are. You might want to write these down. Side, 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 angle, side, and angle, angle. Now what I'm going to do is something I should have done right away. I'm going to move these down, so I want to make sure I have room to give you a really good explanation. Side, side, side does not mean, Tara, you have 3 sides of one triangle congruent to 3 sides of another. What it means is, I'm going to paraphrase this, you have 3 sides of a triangle proportional, and I do know how to write, my computer's freezing up, proportional to the 3 sides of another triangle. Okay, that's what we mean when we say side, side, side. Because in a little bit here, I'm going to start asking you whether some triangles are similar or not. Okay, now let's talk about side, angle, side. And here we go. Now listen to this carefully, please. It means 2, now watch this, Tara, 2 sides are proportional to 2 sides of another triangle Now listen to this. And the included angle, that means the angle in between those two sides, and the included angles are congruent, not proportional, congruent, okay? Let me give you a real quick example of that. If I had a triangle like that, and then a triangle like that, and let's say this is 1, this is 3, this is 2, this is 6, and this angle here is 30 degrees, and this angle here is 30 degrees. Now watch. Here's my side angle, side. Here's my side angle, side, okay? And notice the included angle is congruent, 30 equals 30. And notice 1 was changed to a 2, that's 1 times 2. And 3 was changed to a 6, that's 3 times 2. So both sides are proportional. That would be an example of side angle side. The two sides are proportional to each other, and the included angles are congruent, okay? And we're going to apply this to problems, like I said, in just a couple seconds here, all right? Okay, and then the other... That was real good, wasn't it? Let's try that again. And then the other way to prove that triangles are similar was angle angle. Now here's what this means. This is really interesting. It just simply means if two angles of a triangle are congruent to two angles of another triangle, then we have similar triangles. Now, you might say, Mr. Harrod, how is that possible? Think about it, guys. If I have a triangle like this, and this is 30, and this is 100, then I have a smaller triangle like this, and this is 30, and this is 100. We know all three angles are congruent because 30 and 100 is 130, so we know this has to be 50, and 30 plus 100 is 130. So this has to be 50. So basically, please watch this, Tara. Whenever two angles in one triangle are congruent to two angles in another, well, the third one's congruent too. So really, all three angles are congruent to all three angles. And anytime you have congruent angles like that inside of triangles, you will have proportional, for yawning, you will have proportional triangles, because the sides will have the same ratio. Okay, that's just going. I'm not getting into proof of that right now, but that will happen. So, with all of that in mind, now let's quickly jump into some problems. We have 8 minutes left, so let's really roll. Here we go. I want to get through similarity, if nothing else, today, and then we'll get into some more stuff. And we're going to do a lot of formulas on Friday or on Monday and Tuesday. Okay, here we go. Page 401. I'm going to ask you to turn over there quickly. I'm not going to wait for you, so you'll have to turn quickly. Page 401. We're looking at numbers 8 through 11, okay? Numbers 8 through 11. And here we go. All right, first of all, let's deal with some proportions here. Y over 18 equals 1 over 3. Let's go ahead and make this a 5. Just to make it a little more difficult. Okay. Now I want you to be able, on the test, I want you to be able to solve a ratio like this, or a proportion. And whenever two fractions are equal, you cross multiply. 18 times 1 is 18, and 5 times y is 5y. Pretty simple. And set them equal, and then solve for y. So divide both sides by 5, and you will get 3 3/5, or 3.6 equals y. Okay, very quickly, please look at number 10, if you would, please, in your book, top of page 401. 2/3 equals z minus 6 over 15. All that I wanted to show you here is when you're solving for z, you go ahead and cross multiply because you have two fractions that are equal. 2 times 15 is 30. That's pretty simple. But this 3, when you multiply 3 times this numerator, the 3 does go to both terms. So 3 times z is 3z, and 3 times negative 6 is negative 18. And now you're ready to solve for z. Add 18 to both sides. So if you add 18 to 30, you get 48. Over here, we're left with 3z. Then divide both sides by 3, and 16 equals z. So you should be able to solve those on the exam. Now I'd like you to look at numbers 12, 13, and 14, predominantly 12 and 14, okay? So we have a triangle that looks like this, and then 1 that's a little bigger. And again, I'm not trying to draw these proportionally correct. We have a 10, a 16, a 20, a 15, a 30, and a Z. And the directions, I believe, tell us, yes, the directions say these triangles are similar. They are similar. So we have to find Z. Well, let's go ahead and very quickly here, let's match up our corresponding sides with corresponding sides. 10 is going to go with 15. So I would say 10 over 15 equals 20 over 30. 20 over 30 equals, and then 16 over Z. There. Now look, Tara, we're going to solve for Z. It doesn't matter if you use 10/15ths and put that with 16 over Z, or if you take 20 over 30 and put that with 16 over Z. Excuse me, it does not matter. I'm going to show you it doesn't matter. Okay, watch this carefully. If I cross multiply here, 15 times 16 would be, I don't have that done, sorry, 15 times 16 would be 240. So 15 times 16 is 240, and then 10 times Z is 10Z, and divide by 10, and you get 24 for Z, okay? And now come over here and do the same thing. 20 times Z is 20Z, and then 30 times 16 would be 480, and then if you divide that correctly, you will get 24, the exact same answer. So when you're looking for missing sides of similar triangles, just set up your proportions and then solve for the side that you're missing. Let's go ahead and take a look at one more. Let's take a look at number 14. I feel like number 14 would be really good for us to look at because they have the two triangles turned, and it's real important that you guys learn to match up, or that you learn, Tara, to match up corresponding side with corresponding side. Okay, notice we have 2 marks here, 1 mark here, and then 3 marks down here. And then over here we have 1 mark here, 2 marks here, and 3 marks here. And then we have an 8, and we have a 6, and a 12, and then and then we have a 9x and a 12. So 9x, 12. Now please watch this carefully. 9, do you see this 9 right here? Notice this 9 segment right here has a 1 mark on the end and a 2 mark on the end. Do you see that? And so what side over here has 1 mark and 2 marks? Well, it's this side right here. So 9 obviously goes with 6 equals. Now let's look at the 12. 12, this side right here, has 1 mark on the end and 3 marks on the end. So I'm going to look for 1 mark and 3 marks. There it is. 1 mark and 3 marks. So 9 went with 6. 12 goes with 8. And so then obviously the only side left would be x going with 6. Now it doesn't matter which fraction you use. I'm just going to use this one right here. 8 times x is 8x. 6 times 12 is 72. Divide by 8, and x equals, what would that be? 9, I believe. Okay? And so make sure you always line up the corresponding side with the corresponding side. There's so much more I wanted to cover with similar triangles. That's good enough for today. It's been right at 35 minutes. So let's quickly do the review. We talked about trapezoid, what the bases are, what the legs are, what the mid-segment is, what an isosceles trapezoid is. We talked about how to find the angles in an isosceles trapezoid when you're given one angle. Don't forget the base angles are always congruent. And don't forget that when you add up all 4 angles on the inside of a quadrilateral, they're going to equal 360. And then we talked about how to find the mid-segment if you're missing the mid-segment, and also how to find one of the legs if you're given, or one of the bases, excuse me, if you're given a base and a mid-segment, how do you find this up here? You take the mid-segment in your head, you multiply it by 2, write the number over here, and then these two bases have to add up to that number. And then we talked about triangles being similar. The angles have to be congruent, the sides have to be proportional, and then we did a little bit. So I'm going to come back to this tomorrow on Monday, I believe, Tara, and talk some more about proving triangles similar. If we end up not using this section here, then so be it. It just depends on time. I'll look at it over the weekend and make a decision as to more of what we're going to do on Monday. But I will say this, that we are going to get into some heavy formulas on Monday and Tuesday, and I am going to let you have a little cheat sheet for the final exam with nothing on it but formulas. Nothing but formulas, no steps. You cannot write down what the variables stand for. All you can do is write in the formulas, because there's about 15 or 20 formulas, and I am going to let you do that, okay? And then continuing on, what else did we look at today? Well, we looked at solving proportions like this, and then if you're missing parts of triangles, how to find those. So that's a pretty good review. Not nearly as much as I wanted to cover, but that's not your fault. And we'll pick up here on Monday and get you more and more prepared for the final exam. We're going to talk a lot about areas, surface areas, and volume on Monday and Tuesday. Okay? Have a good weekend.